This is chapter 6 from OpenStax number 61. So we have this mountain climber here, and we know that there's going to be this tension force pulling up on her. And the question asks, what's the tension in the rope? Okay, so we're going to try to solve for that. The question also asks, what is the force that the mountain climber must exert with her feet on this vertical rock? Okay, so here we can use a little bit about Newton's third law, which is kind of imagining what's happening right here. So we can think that she's pushing with her legs on the rock. She's going to push with her legs kind of in this direction on the rock, and the rock is going to push back on her legs in this direction. You see how that's an action-reaction pair? Her legs push the rock like this. The rock pushes her legs like this. The reason that I'm emphasizing that is that the question is asking, what force does she exert on the wall? So what I'm going to do is I'm going to figure out what force does that rock wall exert on her body, and I'll know that those two forces are the same magnitude because they're an action-reaction pair. The reason I'm not just and again, the reason I'm trying to figure out what's the force that the rock wall exerts on her body is that I'm going to draw a free body diagram for her body because that's where I know lots of things about that. I know that what angle the tension is pulling at. I know what her mass is. So I know a lot about what's happening to her body. So I want to look at the forces acting on her body, and that would be the force of the rock wall pushing on her body in this direction. So let's draw a free body diagram. There's the mountain climber. We're on Earth, so we always have mg pulling straight down. That's the force of gravity. The tension is going up at this angle, okay, just like that. And then the rock is going to exert a force on her in this direction, okay. Because they're saying assume that the force is exerted parallel to her legs, so we're kind of up in this direction. That's the rock itself exerting a force on her body. So I know that in order to figure out this force and this force, I'm going to need to add together my vectors in component form. So I need to break this into a horizontal and vertical component, and I need to break this vector into a horizontal and vertical component. So just, this makes me a little nervous because there's an angle with respect to a vertical here. So that is always something to be careful of in the textbook. We're used to always knowing the angle between a vector and the horizontal axis. And in that case, the horizontal component gets the cosine because that's adjacent to that horizontal angle. And the vertical component gets the sine because that's opposite that angle. Here it's backwards. So just to be extra careful, what I'm going to do is I'm going to set up my x and y axes just like this, and I'm just going to be really careful, okay? I prefer to determine my x and y components by knowing the angle with respect to the horizontal axis. So this angle is easy. That one's 15 degrees. So that's going to be easy for me to break up this force that the rock is exerting. To break up this tension force, I'm going to try to figure out this angle here. That's the angle that the vector makes with the horizontal. It's not 31 degrees. 31 degrees is the angle between that vector and the vertical. Like if I had a line coming straight down here, the angle between this angle up here, between the vertical and that vector, would be 31 degrees. I want this angle because that makes it easier for me to break my components. It's the usual way that I'm used to doing it. So if this, imagine there's a right triangle here. That's the hypotenuse. There's a vertical side and a horizontal side. If this angle up here is 31 degrees, this angle here is going to be 59 degrees. So now what I've done is I've just made sure that I know the direction of these two vectors with respect to the horizontal. That way it's easy for me to break up my vector into components because I'm very used to saying, okay, the horizontal component gets the cosine. So I've taken this vector and broken it up into a horizontal component, t cosine 59, and a vertical component, t sine 59. And I've taken this vector here and broken it up into a vertical component, f rock, whatever that is, however big that force is, I don't know yet, but that's just a number. That's the magnitude, times sine of 15, that's my vertical component, and my horizontal component is the magnitude of that vector times cosine of 15. So the question is asking me what is t and what is the force the rock is exerting. So now I need to solve for t and I need to solve for this unknown. So we have two unknown variables. that means it's going to take me two equations in order to solve for both of them. So what I'm going to do is I'm going to write a net force equation for the y direction, and I'm going to write a net force equation for the x direction, and then we'll see where we are. So let's look at the y direction first. I'm looking at the net force in the y direction, so I'm adding together all these forces in the y direction, and I'm adding them together correctly. So in the positive y direction, I have t sine of 59. Also in the positive direction, I have the force of the rock times sine of 15. And in the negative y direction, I have mg. Here I've just calculated what's sine of 59, what is sine of 15, and I've plugged in the girl's mass and g, and then here I've just done that little bit of math. So right now at this point I have one single equation with two unknown variables, so I cannot solve this yet. Oh, sorry, let me mention something else. Sorry. The net force in the y direction is always equal to the mass times the acceleration in the y direction. Well, what is her acceleration in the y direction? It's just 0. She's at rest. She's staying at rest. So the acceleration in the y direction is 0. That means the net force in the y direction has to be equal to 0. That's why I have a 0 here. Okay, so we've got this equation with two unknown variables. I can't solve it yet. But now I'm going to look in the x direction, and I'm going to write a net force equation in the x direction. So the net force in the x direction is equal to, in the positive x direction, I have the force of the rock times cosine of 15, and in the negative x direction, I have t times cosine of 59. Her net force in the x direction is always equal to mass times acceleration in the x direction. What is her acceleration in the x direction? It's just 0. Since her acceleration in the x direction is 0, her net force in the x direction has to be equal to 0. Here I've just gone through and calculated cosine of 15 and cosine of 59. So now I have two equations here with the same two unknown variables. So now it's just up to algebra to solve. So I don't want you to spend all your time figuring out the algebra. If the question asks you for the tension and the force of the rock and you get this far, you've got 9 out of 10 points. Don't spend too much time on the algebra. I'm going to do the algebra super fast. I'm going to solve this for t. There it is. I'm going to plug in this expression into here for t. That's what I've done here. So I took this equation, except I've plugged in for t. Then I solve for the force of the rock. That answers one of my questions. And then I can plug in this value back into here and solve for t. Okay, that was just algebra. So I would say the tension is 512 newtons. The force that the rock exerts on the woman is 273 newtons. That means that the force that she exerts with her legs on the rock is also 273 newtons.